In this video, we are going to be talking about law of sines and how we can actually solve oblique triangles, meaning any triangle that's not necessarily a right triangle, and be able to use the law of sines formula in order to actually find the angles and sides. So the law of sines formula is actually pretty straightforward. It is nothing but a proportion. So if you take the sine of an angle and divide it by its opposite side, that is going to be equal to the sine of another angle divided by its opposite side, which also is going to be equal to the sine of its opposite angle divided by the opposite side. It is nothing but a basic proportion as long as the angle and its opposite side are written together in the proportion. So let's actually attempt a practice problem. We know angle A and angle B. The first thing you have to find in a law of sines is you have to locate the proportion. We have an angle and we have its opposite side, which means we can use law of sines. So the first thing, well, that's the first thing. Second thing, I noticed that I have two angles. And something you learn in geometry, there's a postulate that basically says that all triangles add up to 180 degrees. So if 70 and 55 is 125 degrees, then I know that the other angle is also 55 degrees because they have to add up to 180 degrees. Now, because we have an angle and its opposite side, we can now find, for example, in this case, little b. So I'm going to write the proportion. I have an angle and its opposite side, and I can set that equal to the angle b and its opposite side. And now I can cross multiply to find little b. So little b times sine of 70 is going to equal 12 times sine of 55. So to solve for b, I'm going to divide both sides by sine of 70. And I will get 10.46. Now, in this case, I could create another proportion in order to find little c, but we can actually cheat here because there's another postulate in geometry that basically says if you have an isosceles triangle, and in this case, we do have an isosceles because we have two angles that are the same. That means their opposite sides are going to be the same. So if little b is 10.46, then I know that little c is also 10.46. So in this case, let's try it again using law of sines. First, we need to look for our proportion. Do we have an angle in its opposite side? We actually do not. However, we can find one. Because we have two angles, we can find the third angle of a triangle. 35 and 25 is 60. So if you subtract that from 180, you'll get 120 degrees. So we now know an angle and we know its opposite side. Now we can create our proportion. So the sine of 120 divided by 68 is going to equal the sine of b over little b. And we can go ahead and actually rewrite that proportion again. The sine of 120 over 68 is going to equal the sine of a over little a. And now we have two proportions that we can go ahead and solve. So we have b times sine of 120 equals 68 times sine of 25. And so to solve for b, we will divide. And then little a is the same. A times sine of 120 is going to equal 68 times sine of 35. And divide. And now we can put these each into the calculator in order to find our answer. So little b is going to be 33.18 and little a is going to be 45.04. So we have found all three of our angles and now we have found all three of our sides. Now sometimes you're going to be given the information without given the triangle, which nothing changes. You can still be able to just draw a triangle and then write out where your angles are going to be. It doesn't matter which one. So if I'm going to say that that's A, that means that must be little a. If that's B, then that must be little b. And if that's C, then that must be little c. We know that angle A is 70. We know that little c is 26. And we know that little a is 25. Okay, first thing you do you have an angle in its opposite side? Yes. We have an angle and we have its opposite side, so we automatically can create the proportion. Next, we need to determine what we're going to find next, which, because we have little c, that means we're going to have to find big C next, because we don't know anything about either of these. So our proportion is the sine of 70 divided by 25. That is going to set us up to the sine of angle C divided by little c. So to cross multiply, I'll get 26 sine of 70 equals 25 sine of C. So to solve for sine of C, we're going to divide. Now, you cannot divide by sine because that angle is attached to that trig function. So the first thing you're going to do is you need to find what this is as a decimal, and you will get 0.9773. I'm going to use a couple of decimal places, because the more decimals you use, the more accurate your angle is going to be. Now, back in right triangle trig, we discussed how to find an angle, and this is where you would have to use the inverse. So in order to find angle C, you will actually take the inverse of your sine to find the decimal. So second sine in angle C will be 77.8 degrees. So we have now found angle C. Now that we know angle A and we know angle C, we now can find angle B, because a triangle has to add up to 180 degrees. So 70 plus 77.8, and subtract that from 180, and you will get 32.2 degrees. So angle B is going to be 180 minus 70 minus 77.8. Now that we know angle B, now we can find little b. So we're going to take our proportion, which is sine of 70 over 25, and we're going to set that equal to the sine of B over little b. So put that in the calculator, and you will get little b of 14.2. And we have now found all three angles, and we have found all three sides. In this case, something interesting is going to happen. So if we were to draw out this triangle, let's say that's B, which would be 100, and we know little b is going to be opposite of that of 29. And let's just say that's A and that's C, and we know little a is 33. So the first thing we're going to have to find is angle A, because we know little a and we have a proportion. So therefore, sine of 100 divided by its opposite side is going to equal the sine of angle A over its opposite side. When you cross multiply, and then to solve for angle A, if you were to put this in the calculator first, you will get 1.12 equals the sine of A. Now, in order to find an angle, this is where you have to take the inverse. So the inverse of 1.12, if you put that into the calculator, it is actually going to give you an error domain. And here is why. In a triangle, there is a postulate back in geometry that states that the biggest angle in a triangle must always be opposite of the largest side. And that actually does not happen here. The largest angle we automatically know is 100 degrees because you cannot have two obtuse angles in a triangle. So if that's 100, I know that these two angles have to be smaller than that. That means if that's the biggest angle, that means the opposite side has to be the largest side, and it's not. Little a is 33, which is bigger than little b. So I automatically know that this triangle is not possible. So your answer would either be not possible or no such triangle exists. But in any case, you cannot solve the remaining information needed because there is no triangle that actually can be made up using these degrees and these numbers. Now, you can use law of sines with real-world connections. So in this case, let's say you have a ship that is sighted from 2 Coast Guard observation posts, and they state what the angle between those are. And they want to know what is the distance from the Coast Guard post A to the ship. So they're wanting to know that unknown variable. So the first thing you have to determine is there an angle and its opposite side to create a proportion from? At the moment there is not, but you can make one. Because you have 2 angles that are known, you can find the third angle. 110 and 30 is 140 degrees. So if you subtract that from 180, you can get the remainder angle. Now I know an angle and I know its opposite side. We can actually use law of sines. So sine of 40 divided by 15 is going to equal sine of 30. Why do I use 30 instead of 110? Because that is opposite of the unknown that I need to find. So opposite of 30 degrees is going to be our unknown length that we need. So to cross multiply, x times sine of 40 is going to equal 15 times sine of 30. So if you put down the calculator, you will get 11.67 kilometers as a distance from observation post A to the ship. In this case, this is a little similar to one that we did with the right triangles in order to find a side. But in this case, what we're going to do is we're actually going to find, using law of sines, we're going to find an angle first before we go further. So one thing I know that if that is 75 degrees, there's a postulate in geometry again that states that if you have a straight line, that the 2 angles are going to add up to 180 degrees. So if that's 75, then this angle must be 105 degrees. Now that I know 45 degrees and 105, I can now find that angle. 105 and 45 is 150. Subtract that from 180 degrees, and I know that that's 30 degrees. I did that because now I have an angle and its opposite side. Once I find that, I can find another side. I can't find the tree yet because I can only stay inside this triangle. So I'm going to go ahead and find this unknown variable because then I will have a right triangle with the side known in order to find the height of the tree. So first thing I'm going to find is x. So I'm going to take my proportion, sine of 30 divided by the opposite side is going to equal the sine of 45 divided by its opposite side. So I'm going to cross multiply. And divide. And I will get 28.28. So I know that that height right there is 28.28. And now I can use this triangle right here in order to find my height of the tree. So this is where you can actually use SOHCAHTOA again because this is a right angle, assuming that the height of the tree that the tree is vertical. So I now can actually find the height by using SOHCAHTOA. According to this angle, this is your opposite and this is your hypotenuse. So you will use sine. So the sine of 75 is going to equal the opposite divided by the hypotenuse. So to solve for h, I'm going to multiply and I will get the height of the tree, which is 27.3 feet high. So in this case, I would like for you to pause the video, attempt to work this problem, and then resume to see the answer. Okay, we have fire towers. That's A, and fire tower B. They are 10 miles apart. They spot a fire, so we need a fire. There's a fire. Fire. We need some orange in there. Fire. Okay. So we have a fire. They spot it at 42 degrees from A. So if I was to draw a line of sight, then this would be 42 degrees. And the Rangers spot the same fire at 64 degrees of their line of sight. They want to know the distance from Tower A to the fire. So we have a side, but we don't have its opposite angle, but we can find it. If we know two angles, we can add them together and subtract from 180. So 42 and 64 is 106. So subtract that from 180 and you will get 74 degrees. Now we have an angle and its opposite side, and we can now find our unknown. So sine of 74 divided by its opposite side is going to be equal to sine of 64 divided by the unknown. Why did I use 64 not 42? Because 64 is what coordinates with its opposite side. 42, we don't care about the opposite side of B. We are only want to know from A to the fire, so we need to use 64. So to cross multiply x times sine of 74, and we're going to now divide. And we will get 9.35 miles.